Hi, this is an introduction to the topic of limits in the course of differential calculus. And just for starting out, this idea of limit in mathematics, it's something extremely important, very important. And it is because the whole area of calculus is based upon this topic, this idea here of the limit. Now, the good part is that this idea of the limit of it's something very simple. It's a very simple idea, but and yet it's extremely powerful as a mathematical tool. And in order to explain it, I'm going to start right away with a function here. I'm going to start with this f of x equal to x squared minus 1 over x minus 1. And now, this is a very simple function, and I'm pretty sure you can notice that you can simplify this out by using factoring, but I'm just going to leave it just like it is in order for explaining purposes here. And now the first thing is I'm going to ask what happens if I evaluate this function with a value of 1. If you input the 1 to this function, you will get to a 1 minus 1 denominator over 1 minus 1 denominator, and you get to this terrible 0 over 0. This is something very bad in mathematics. It's the undefined here, the 0 over 0 is something really bad in mathematics, and we have to work this through. Let me just focus. This is something really bad. I'm going to show you this, how bad it is. This is bad. This is a bad thing, the undefined thing. And you should notice here that this f of x has to be restricted in order to work this through. This x minus 1, we have to make sure that this x minus 1 has to be different from 0. So x has to be different from 1. We can just stand this out. And now I already have the graph for the f of x here. I'm going to show you. I'm going to place it here on the right. And here's the graph for this f of x. I'm just going to name it here. This is f of x here. And the thing is, you should notice here, this is an open circle here because I'm excluding the value of 1 starting from this condition. But I'm sure you can notice that perhaps just as it is, we may not see directly, but here by looking at the graph, we can see that this function is, when you input the value of 1, it should be a 2 as an output here. It should be a 2. Now, the thing is, a limit is very useful as a tool just when you may have some super weird function, or you're just wondering what would happen if I approach to some value, some random value or something, in order to prove what would happen. And the thing here, this is a very simple example, and you can just notice it's getting to a number 2, and the tool, this limit is based upon the question is what would happen if I get really close to the number 1 but without touching it. So for example, if I would input a value here that it's not 1 but very close to 1, I could say I would input the value 0.999, which is nearly 1 but it's not 1. So if I would input this value, I would get something really close to the actual value of 2. And this is, if I would say, okay, I can input a value as well, it's really close to 1, it's just a little bit above 1. I could get close to 1 from this side as well. I could say, I could input here the value 1.001 here, and as an output here, for f of x, I would get close, really close to the same value of 2. And well, basically that is the idea behind the limit of a function. It relies upon trying on this question. I'm going to place a question here below here. The question is what happens when you get closer and closer to a value. Now here by you, I'm saying what will happen to a function, of course, here. But I'm going to work through this example here below, so you notice how we can use limits to solve this out. First, I'm going to start with a notation of a limit here. Notation for limit is written like this. It's an LIM, that stands for limit in mathematics. And now below the LIM, you have to write X. It is read as the limit when X approaches. You use this arrow here as it stands for approaches in mathematics. In this case, you have to place then here a value. This will be the limit when X approaches to 1 in this case for f of x, and f of x in this case would be this one here, x square minus 2 minus 1 over x minus 1 here. Now, to work this through, we can use factoring to work this through. So I'm going to do that here just to show you how to solve a proper case here for a limit. Here would be, you have to factor out the one in the denominator as x minus 1 times x plus 1 all over x minus 1, and here you can cancel out this x minus 1 and the one below, and then you get to a limit when x approaches to 1 of x minus 1. Now, normally, by doing this step here, you already skipped this undefined situation, which is really bad here. And here, once you get here, once you skip the undefined situation, you can actually just substitute the value that you're trying to approach here for the x. In this case, I will substitute here. So it would be at the end a 1 plus 1, and you get to the final result will be a 2, which is the one we found here using the graph. I'm just going to write here below the final statement here. The limit when x approaches 1 for f of x, it's equal to 2.